Hello guys, am I audible to you?
Yes, ma'am.
Okay, so we'll just wait 2 more minutes or 1 minute, then we'll just start off with today's presentation session. Okay. Okay, guys, so who wants to present? Just let me know.
Ma'am Aditi.
Okay, Aditi. Yeah. So after Aditi,
Ma'am, Sangeet, ma'am.
okay.
Shyam.
Okay, Aditi, then Sangeet, then
Himanshu,
Shyam
ma'am.
Sajid.
Himanshu. Okay, Sajiruddin then. Okay. Then
Dikshant.
Dikshant. Okay. Okay, guys. So we'll just start off with them, then eventually, if accordingly, we'll just go ahead. Okay. So Aditi, you can just present your screen.
Yes, ma'am.
Yeah.
Ma'am, is my screen visible? Hello?
Sorry, your screen is visible, but your voice is a bit low. Can you just try and speak a bit up?
Yes, ma'am. Hello, ma'am. Can you hear me now?
Yeah, yeah. You can start, Aditi.
Yes. Ma'am, I have done the project on the Parkinson's disease detection using vocal biomarkers. So the project is based on the ANN, artificial neural network. So the first I have done this step of data loading plus exploration. Here I have used the UCI machine learning respiratory. Here there are 195 in my data set. There are 195 voice recordings from 31 individuals. Here features are 22 biomedical voice messages, like example NHR, HNR, shimmer, jitter. So here I have loaded the data for my personal and the project visualization. I have inserted a diagram here, a plot diagram, in which basically we can see that 1 is mentioned for Parkinson's disease and 0 is for healthy person. So here the status is 1 have 147 counts, which is 147 people, for example, are being Parkinson's disease diagnosed, and there are 48% which are normal. So here the correlation map gives us the basic idea of whatever the we have data here. It is the just example in the correlation map. And the third step is pre-processing. Here I have just pre-processed and the trained data where it is come from 195 to 156, 22 and 39, 22. Means here the it is been filter out that whatever the it's for example we have considered one as the Parkinson's disease, so the data is been pre-processed here. So the baseline comparison I have used logistic regression and SVM. So the logistic regression gives us the accuracy of 0.92 and SVM results gives us the 0.95. The ANN model have 22 features which are the vocal matrices. Here we can see their dense output shape and param hashtag which are 128 and the dense is 128, the batch normalization is 128, the dropout is 128, the dense is none and 64. Like dense and dropout 1 are same and dense 2 is 1. So the total parameters are 11, 777. Trainable params are 11, 521 and the non-trainable params are 256. The training batch size is 16. Epochs are 100 with earlier stopping. Validation split is 15%. So here the epoch has been done. The accuracy for each is different and varies accordingly, and the laws they are kind of similar, but there is a difference in their point wise, as we can see here. The next I have added the learning curves. In this we can visually see the epochs and losses. The blue lines represent the train loss and the orange line represents the value loss. As I have mentioned the two diagrams according to the losses. And the seventh one, the next process is evaluation, where accuracy, precision, recall, F1 score, ROC, AUC are been done here. So here I have just added the confusion matrix for the better visuals. The ROC, AUC percentage here is 0.97. The recall, the precision, F1 and the support are also been mentioned here. The confusion matrix and the next diagram which shows the true positive and false positive. The SHAP explainability, which helps the interpret black box models like neural networks. The summary plot shows which features, means like voice biomarkers, have the most influence on the model's predictions. This adds clinical insight. For example, features such as Jeter and NSHAR may have stronger contributions to detection Parkinson's. So here there is a just visual representation. There's each dots with different colors represent the data which we have done here. Like the here we have installed some of the SHP, and the summary plot shows the name and status of the uh, individuals. Means the accuracy we are seeing from minus 0.25 to 0.00 to 0.25, means the data has been seen into the negative terms and the positive terms also. And the each step I have just done here, like I have just uploaded voice recording. So the voice recording is just normal, like hi, hello and all. And just for the demo I have just uploaded it here, and which is MFCC features vector length, means it shows 1 and comma 40, means it is the vector and the size of the MFC feature vector length. In short, it is the vector length. So for the next, to understand the MCC, means the recordings, visualization I have done here with the correlation heat map. And the ninth one is the extensions, where means what are the extensions I have used, like the logistic regression and SVM used on benchmarks for ANN, SHP, then prototype MFCC, Flask, training, CNN, LSTM, extended evaluation on larger real world data set with medical collaboration. And the tools I have used, like Python, Google Colab for data handling and data processing, like Pandas, NumPy, Metaplots for visualization, Metaplot C-burns for deep learning, TensorFlow cares, explainability, SHP, audio processing. I have used the MFCC extractions, and for future development, we'll be going with Flask and Streamlit. Yes, ma'am, I'm done.
Eh, So did you did the deployment or that you have just kept for the future reference?
I have just kept it for the future reference right now.
Okay, okay. Okay, got it, Aditi. So
Yeah, ma'am.
which model worked best for you?
Mm, SHP explainability, ma'am. Means it
Okay,
shows
so
the, yeah.
mhm. Yeah,
And I
carry on,
have,
please.
yeah, in this SHP explanatory, I have just shown the diagram.
Okay, so like, did you get like counted the accuracy or anything like that?
Yeah, ma'am, accuracy for this, sorry, ma'am, for this actually I didn't counted it to be specific, but I have done it for the this ROC curve.
Okay, got it. So
Yeah.
linearly, if you have just taken the like the supervised one as well, sorry, unsupervised as well, right?
Yes, ma'am.
I guess SVM you have taken into account. So
Yes.
what are the results for that? The accuracy part.
For what, ma'am? I didn't hear you.
SVM, you have plotted it with SVM, right?
SHP, ma'am.
No, no.
Yeah, yeah,
Didn't you
here.
take?
Logistic, yeah, yeah. Logistic regression
Yeah,
and SVM, yeah, yeah.
yeah. So what is the data up there? What is the accuracy level of them?
In SVM, it is 0.95, and in the, logistic regression, it is 0.92.
Okay. Have you checked? Is your model overfitting or anything?
Uh, Means overfitting in the terms of,
Like, suppose you are checking on and you are getting, suppose the validation score, like accuracy, you are getting something else, but in general, the accuracy, you are getting something else. So you are just, have you checked it whether your model are like suffering for overfitting problem or not?
not yet, ma'am.
Okay, fine. Okay, Aditi. So you can just stop your screen sharing. Okay.
Okay, ma'am. Thank you. Huh.
Yeah. Okay. Next is Sangeet. Sangeet, you're there?
Yes, ma'am.
Yeah. You can start with your presentation, Sangeet.
Yeah. It is visible.
Yes, it is visible.
Good evening to everyone. Today I'm going to present the approval predictor project. First I have used the 9 steps: objective, data analytics, pre-processing, and model architecture. And I also used it as a fifth step of training and evaluations and extensions. 7 steps and tools. What are the tools I'm going to use and conclusions? First, let me see about what is my project. In this project, we are going to check the approval predictor that your loan is going to be approval or it going to be reject. So we are using the artificial neural to predict that one, and we are using the tools such as Python programming. We are using Python programming, and for data analytics we use pandas and numpys, and pre-processing sketchlearns, and model building we are using keras, tensorflows, and for visualizations we are using MetaLab and Seaborn. First, we are seeing the objectives of the program. The objective of the program is building a machine learning using artificial neural network that can accurately predict whether a loan will be approved or rejected based on the applicant and loan details by leveraging futures engineers data pre-processing and deep learning techniques. The project aims to assist financial institutions in making faster and data-driven and unbalanced loan approval, thereby reducing man effort and improving efficiency. Data sets. I have taken these data sets from Google. what are the data sets contains? Application incomes, co-lab income, co-applicant income, loan amount term, credit card history, categories, variables, gender, married, education, self-employed, property area, targeted variable, loan status, approved or not. So pre-processing, I use the third step as a pre-processing. We are handling missing values by filling missing data by using forward, fill, or mean imputations. Encoding, we are encoding, converting categories features into numerical using label encoding. Scaling, we are using normalized features using standard scalar for stable artificial neural networking training. And then we are splitting data, training data, train test, we are taking 80 to 20 ratio. As a training data, 80, test data, we are taking 20 ratio. So model activities, the project uses artificial neural network built with Keras, TensorFlow's backend. The architecture is designed for the binary classifications, loan approved or not. Layers, we have taken input layers for the number of neurons. We have taken number of example 10 to level features like income, credits, etc. Reduce pre-process and scale data. Hidden layers, 64 neurons, activity functions. Drop out 30% to prevent overfitting because we have some overfitting here. So we are using dropout to prevent that for overfitting. And hidden layers, 32 neurons are there. Activity functions, outer layers what we have taken, one neurons, activity functions, sigmoid outputs properly of the loan approval. Next, we are going to train loss of the functions, binary cross entropy, optimize random aptitude learning rating, batch size we are taking that 32, approach we are taking 50, can be turned with eagerly stopping. And approach as several meanings, refer to the specific instance in that serves as a refer point for calendar era like J2000, a long period in history of or geology made by important events or characters, or in the machine learning, one completely passes through entry data sets. And evaluation matrix, we used accuracy, overall the performances and precision, correctly predicted approvals out of the total predicted approvals, recalls, correctly predicted approvals out of the actual approvals. Next, F1 score and confusions matrix also we have used breakdown of the true positive, true negatives, false positive, false negatives. And extensions, we have had a hyperparameter tuning. Try other ML models like random forest, SG boost for comparisons, and deployment flask job web for the real-time approval predictions. Use a long real-world banking data sets for the robust and tools. We are already have decided what are the tools I am using, and let's be going into the coding section. So I have used this here. What I have tools I have used here, and we have load the data sets, and we have encoded the categories and features and targets and scale features, and we have train and split the data, and we have the evaluation matrix, and we confusions the matrix heat map, and we if we run the program here we get that output, and approaches what we have getted accuracy loss, value accuracy, value loss. And here we see the what accuracy I have got, and precautions and recall value, and F1 score value, and confusions matrix. Accuracy curve, it shows that the blue curve shows that train accuracy, and the orange will shows the value accuracy. Here accuracy we are taking epoch, and here in this diagram we are see the losses, what losses here, and epoch. Here the train blue color shows the train losses, and orange color shows that value losses. And here we are seeing the Confucius matrix, predicted value, predicted positive and actual positive and a true label, actually negative. And we are going to finally see the conclusions of this project. The loan approval project successfully demonstrated how the artificial intelligence neuron can be applied into the predict loan approval outcomes based on the applicant and financial details by performing future engineers, data pre-processing and model training using Keras and TensorFlows. The system achieved promising accuracy and reliable. Ma'am, that's all, ma'am. I'm done. Ma'am?
Yes, Sangeet. Actually, I was
Yeah,
facing issue with switching on my mic. Actually,
yeah,
there was some issue with the mic. Yeah,
yeah. Okay, ma'am.
yeah.
Okay.
Okay, got it. So eventually, what is the accuracy level you have checked for the project?
Ma'am, here the accuracy level, ma'am.
Okay,
We,
so
we
it
have
is
got that output value 0.6800, ma'am.
okay. Okay, so 68% accuracy you're getting
Yeah,
over, right?
yeah, ma'am. Yeah, ma'am.
Okay. Just show me the training part and the project in the model part. Go up.
Yeah, yeah, yeah.
Not in yeah. Go up. Okay. Yeah. So
Yeah, in the training
I
model, we have taken 20, approach 20, ma'am, and batch size 32, ma'am.
got it. So try and increase the epoch. Okay. So try and increase it to at least 30 epoch. And if
30.
possible, yeah, 30 epoch. And here actually try and use another dense like before the output layer, that is the model add dense one where you have added, try and include another dense with ReLU activation function, or try and use the dense with something else like dense, that is the neurons, try it up with around more in number, or try it with 22 and check how the accuracy level is coming, because since your accuracy is coming up to 68%, so if possible, it is fine, or if it is working in this form, that is good. If not, try and backtrack. I have given you the theory part, like how you can just backtrack and update your weights and bias so that you get the accurate result. So try and work with that form so that your accuracy level increase a bit. At least 80%, like if it is going above 70 to 75%, that is fine, because 68 it's okay, but you do have a chance to work accordingly and make your accuracy better, right?
Yeah, yes, ma'am. Yes, ma'am.
Okay. But just scroll it down.
Yeah, yeah, yeah. I'll do. Yeah,
Just scroll down in the section where you have got the epochs along with the values.
yeah, yeah,
Scroll down, not up. Scroll down,
yeah, yeah.
scroll it down. Where you have got the epochs, like scroll down more. Why are scrolling up? Scroll it down.
Yeah, yeah. Sorry, ma'am. Sir.
Yeah. Okay. Just up. Yeah. A bit down. Where your epochs are ending, like,
Ma'am, wait, ma'am.
yeah, wait. So your
20,
values,
20, ma'am.
yeah. No. I'm just seeing here the last epoch, that is 13 by 13, that one. In the
Yes,
20th epoch, actually, there you can see the value loss that you are counting up to 0.6. So your
yes,
loss
ma'am.
is around, for value loss is 0.6 and the loss is 0.5. So you can
Yes,
see
ma'am.
here that your loss is going a bit high and your accuracy in epoch 20 is coming up around 0.73 and the value accuracy is carrying up to be 0.68, right? So
Yeah,
see
yes,
here is
ma'am.
a major difference in the accuracy part and also in the loss section. So your loss means the difference between the actual and predict is going a bit high. Right.
Yeah,
So
yes, ma'am.
try and
Yes, ma'am.
work with that. If it is working, that's fine. If you can able to manage or can work with that. Okay.
Yeah, yes, ma'am.
Okay, Sangeet. Yeah. You can
Yeah,
just stop your screen sharing.
yeah, yes,
So
ma'am.
next, yeah. Next is Himanshu. Himanshu, you can present your screen.
Okay, ma'am. So my screen is visual, ma'am.
Yes, it is visible.
I can start.
Yeah, definitely. You start.
So good evening, everyone. This is my project is about detect fraud, credit card and transaction. We are using supervised and unsupervised. Sorry. This is overview of my project and detect card transaction using AN and supervised and integrate PC and TSN cation and supervised when dimensionally reduction and visualization clustering insight load and processing data set scale amount and time apply PCA for dimensional reduction split data handle and imbalance with smooth ran NNN without dropdown and clearly drop evaluation evaluate classification report and Rockock confusion matrix visualization transaction with TCN apply k-means and PCA components to compare clusters with levels requirements. Here we requirements Python, Pandas, NumPy, Scikit-learn, imbalance, learn Matplotlib, C1, TensorFlow, and results AN achieve high accuracy and ROC is imbalanced data. ROC improve training efficiency. TS, TSN shows clearly separate or genuine broad k-means cluster align with actual support and analytic detect and anomalies and real-time fraud detection. Here we are using Kaggle credit card fraud dataset also hosted by TensorFlow. It contains analyze and features amount time version 1, version 2 and version 28 amount time and target level class genuine fraud. Uh, the this cell load the dataset into pandas, print int shape and show the first few rows of confirmed successful loading. After this, we using pre-processing description. In pre-processing, we are separate features and labels, scale the amount and time columns, apply apply PCA for dimension reduction, split into training and testing set, and use smooth to balance the rare fraud cases. Be using pre-processing step. This code separate the data set into features X and target Y and apply standard scalar to normalize amount and time. After this, be using pre-post PCA for dimensional reduction. Here be to 10 components. This make training more efficient and reduction noise in the data. After this, we use train test split dataset into training and test set. This then it applies mode which generate synthetic example of fraud cases so the data set becomes balanced. After this, uh, we use print the data set and after this we use build an model with drop down. We use cancel an and it consists of dense layer with ReLU activity drop-down of regularization and a final sigmoid output layer for binary classification. We also add early stopping to prevent overfitting. This code builds this sequential AN model and complies it with Adam optimizer binary and cross entropy loss and prepares it for training. After this train model, we use with 20 epochs and base size is 20, 256 large due to big data set. Here, training data set using early stopping, which stop training once validation performance stop improving. Model evaluation cell. After training, we evaluate the model using classification, report confusion metrics, and Rockoff score. These metrics show how well AN detect fraud cases. Uh, After these are my epochs, 20 epochs, and after this we evaluate the ANN using classification, report, Rockoff, and confusion metrics training course. Uh, Visualization with after this we use visualization with TSNE TSNE and reduction. After after we use confusion matrix plot and confusion matrix plots. Confusion matrix plot figure out the 6 to 4 and SN heat map uh, are not true and a genuine and fraud plot confusion matrix actual prediction actual. Hello ma'am, my voice is breaking sometime.
No, it is audible. I can hear you properly. You continue.
Okay ma'am, here we using confusion matrix after training curves. These are my epochs accuracy result and accuracy versus epochs and loss. Uh, just a minute, something I mentioned. These are advanced visualization with TSNE. Week 4 concept, we take a sample of 1,000 transaction to avoid memory issue. We evaluate the model using classification report and TSNE help visualize the fraud versus genuine and here sample size is 200 and sample. After we evaluate the model using classification report, confusion matrix and Rockoff score. This is my TSN visualization of transaction and true levels. After this, we use clustering with k-mean. Here we train the ANN. Here we train the ANN. We apply unsupervised k-mean clustering on PCA transaction feature visualization clustering. Clustering k-mean clustering 2 and random 42 and cluster k-mean fit sample and we train the model AN balance training data using early stopping which stops training once validation performance stops. After this is my conclusion. In conclusion, this project successfully demonstrates how machine learning can be detect credit card fraud, data loading and pre-processing Our ANN achieve high accuracy and ROCAC even in imbalanced data, PC reduction dataset dimensionally and improved efficiency. TSN is so clearly separate between fraud and genuine transactions. K-mean clustering further validation that fraud cases have distinct patterns. Overall, this combination of supervised and unsupervised techniques provides strong insight and supports real-time fraud detection system. That's it, ma'am.
Okay, Himanshu. So, your presentation was like that as if you are reading from somewhere.
No, ma'am.
Okay, so don't just go ahead
I
with that.
note some point. That's why I note some point in my
Got it.
notebook.
So you just show me, got it. You show me the TSNE, the plot you have prepared. Just show me that one.
Okay, ma'am.
You need to go down, not up.
Yes, ma'am. Yes, I am
Go down. More. Yeah, the
this.
plot. So see,
Yes, ma'am.
yeah, see here, your data set contains class 0. Maybe that is the not fraud one, right? 0,
Okay.
what class 0 is? Not fraud?
Yes, ma'am.
You don't know what 0 class is signifying here?
Yes, ma'am.
Maybe
Here,
according to your data, maybe 0 class is signifying not fraud and 1 is signifying fraud data. So your
yes, ma'am.
data set contains more number of not fraud and only very little percent you are getting that is fraud data. So it is difficult, right, to get along with that. So what you did for this in the pre-processing section? Did you did
Oh,
anything in the pre-processing section to solve this problem, class imbalancing problem?
no, ma'am.
Sorry, there
Just
is
a
a
minute.
class imbalance, right?
Yes, ma'am.
So did you did anything to handle this problem in the pre-processing part?
Uh, Classification imbalance is when one class.
Not class, yeah, this is class
Mm,
imbalancing. There is where it
yes,
happens
ma'am.
when one class contains very more number of data and another class contains very less data, like in comparison,
Yes, ma'am.
right?
The
Okay, fine,
model,
leave it. I got it. You leave it. You just show me the model that you have prepared. What is the accuracy you have got?
ma'am, ANN model.
Yeah, ANN model.
Uh, this, this, ma'am.
The accuracy,
Accuracy, ma'am. I got by AN model 98%.
98%. Okay. So it's fine, but try and check if there is any overfitting because your class, the data is like class misbalance is happening. There is a difference in the data where like if it is not fraud, the data is high, and for the fraud, data is very less. So there is a chance that your model might get an habit of overfitting. Okay, that is it is training good with the training data, but for the test data, it is not performing that well. So try and
Okay,
check
ma'am.
with that once if there is any overfitting issue or not. Fine.
Okay, ma'am.
Yeah, Himanshu, you can just stop sharing. Next, next is Sajiruddin, right? Sajiruddin, you can just share your screen.
Okay, ma'am. Is my screen visible?
Yeah, your screen is visible, but your voice is breaking in between.
Mhm. Ma'am, is now clear?
Yeah, Yeah, clear now. Clear.
Okay. Ma'am, my project is based on the NLP. It is emotion detection from the text. I have used the Twitter data, Twitter tweets for the emotion detection.
Sajiruddin,
For the,
again, your voice is breaking. You can just try and rejoin. We'll wait for you for 1 minute. You just rejoin and start because in between your voice is breaking.
okay, ma'am. Good evening, ma'am. Is my voice clear?
Yeah, now it is clear. You can present
Okay,
your
ma'am.
screen.
Okay, ma'am. Good evening again. My project is based on NLP. It is the emotion detection from the text. For the text, I have used the Twitter tweets. Source of the data, data is given. The data set contains text with the different labels. The labels are joy, sadness, angry, and fear. For that, starting with the coding section, I have installed a library which was not previously installed on the lab. I have necessary imported the necessary libraries that includes pandas for the pandas and NumPy for the visualization, matplotlib seaborn, and for the natural language processing, natural language toolkit. After that, I have loaded the dataset, created a copy, and displayed the dataset. From here, we can say that only the labels are given from which we are not able to understand what it signifies. For that, I have created a map function and map the values with the dataset. This map function is from the I have collected from the data source from where it was given what values signifies which emotion. For the data view, I have first checked the null values and again I have dropped the emotion column as it was not needed for the further development. Uh, I have checked the duplicates as
Yeah,
there were some
Sajiruddin,
duplicates
in
present.
between your voice was breaking. Sajiruddin, your voice was breaking. Can you come again the last section that you have told? Like before
Uh,
you have added that part.
uh,
Yes, this yeah.
uh,
From here you can
okay,
start it.
no problem. As we can see from the earlier data, the labels were in the encoded form, which was not easy for us to understand which value shows which emotion. For that, I have created a map function and have mapped the values. For this map, I have taken this from the Kaggle source, from where it tells us about the which value signifies which emotion. After that, for the review, first I have checked the null values as there were no null values. After that, I have again dropped the emotion column as it was not necessary for the further analysis. Okay, after that, I have checked the duplicate values as there were some duplicate values. I have dropped them. As my data set was quite large, containing 4 lakh text, so that I have performed first EDA, small checking the distribution of the data set. From here, we can see the percentage. I have displayed this percentage into the pie chart, from where we can easily see that the top 3 emotions are joy, sadness, and anger. After that, fear, love, and surprise having the lowest distribution. For the text analysis, I have checked the number of created columns for the number of characters, number of words, and number of sentences. From the number of sentences, we can see that it is constant, that is one, as mostly tweets are considered as single sentences. So after that, I have described the dataset to check the statistical values of the numerical columns like num characters and num words, their distribution, mean distribution and standard distribution, and max values. For summary statistics, I have checked for the top three emotions, that is joy, sadness, and anger. For joy, we can see the its distribution containing 1,20,000 values, sadness containing 1,40,000 values, and anger containing 57,000 values. For word count distribution, I have also created a histogram to see the distribution of the words. From here, we can see that the most number of words are 60, as there are very less number of outliers after the 60 value. After that, I have for data visualization, I have plotted a pair plot to see the features correlation between them. From the number of characters, we can see that it forms a linear uh, correlation between the among all each other. The label distribution here tells the which value represents which emotions. From here, we can see that it all correlated as they are all overlapping each other. For that, I have created a correlation map. From correlation map, we can see that the values are very near to zero. That is, there is no correlation between them, but they are overlapping each other. So that I have created a pipeline, data preprocessing pipeline, in which I have lowercase the text data, remove the URL links. I have also removed the username, hashtag. I have also converted the emojis if present into text so that it is easy to for pipelining, easy for modeling, tokenize the words. But here tokens were not giving much better result. I wanted to use lamentation for further analysis that I have kept for the future analysis. I have converted into alphanumeric form and removed the stop words. This was my pipeline for transforming the dataset. Here I have transformed the dataset and displayed the transformed data. From here, we can see that feel becomes feel, awful becomes awe, but it can be also be word can also be awful. So that why there was some little problems with the tokenization. After that, for the model development, I have used a CNN model as it helps in extracting the features using filters. For filters, I have used filters of size 2, 3, and 4. That is bigram, trigram, and foregram, such as sad, not good, can be considered bigram. For the trigram, I love this, can be considered in the trigram filter size. So after collecting the filters, I have combined all the features so that it can help in improving the accuracy of the model. Before that, I have embedded the all the feature, all the text, so it converts into a vector database. We can also use Globe or Twitter embed Globe, which is a pre-trained embedding provided for the Twitter analysis. After that, I have summarized the model, and here is the summary of the whole model. Here I have used input layer, embedding layer, convolution layer 3, 4, 5, and after that I have used the global max pooling, which helps in retaining the most important character or feature of the text. I have also used a dropped out with the value of zero point 0.6. Earlier I was using zero point 0.4 and 3, which was giving me overfitting. Even after using value of zero point 0.6, I still have a little bit overfitting in my model. From here, we can see the I have used 5 epochs as the data was quite large. It was taking a last time for training. From the model accuracy, we can see that the after the first epoch, the accuracy of the training increases a large quickly, and it goes till the 93.4%. From here, we can see the highest is 93.24%. And while the validation accuracy after the first epoch, it starts after the second epoch, it starts decreasing, which shows the case of overfitting. As my model is working fine on training data, but it is not able to work much as excellent as training data on the on the unseen data. From the plot loss, we can also see that the training loss is gradually decreasing, but validation loss after a certain first epoch it starts increasing, which is the case of overfitting. For for verification, I have used a ML model, logistic regression to check the accuracy of that model. Here I have displayed the confusion matrix of the logistic regression. From here, we can see that the accuracy of the logistic regression is 87%, which is quite less than my CNN model, which was 93%. Here I have shown a comparison by using a bar plot. I also wanted to use some other models, but due to the size of the data set, it was taking quite a large time to train. So I have just used the regression model, logistic regression. With this, I conclude my project as it was a CN-based deep learning model for emotion detection.
Okay, Sajuddin. So your model eventually just go ahead with some of the overfitting issue, right?
Yes, ma'am. As it was accuracy was near 91% for the test data.
Hmm.
Here I have printed 90, which was quite large. For more accuracy, I have checked that I have to use some pre-trained models or I
Right,
use
right.
some embedding techniques.
Hmm. Absolutely. So if that is fine because there is some overfitting. If you want to check it through, try and use any
Ma'am,
of the
your voice is
pre-trained.
breaking.
Yeah. Hello. Is it fine now? Can you hear me properly?
Yes, ma'am.
Yeah. So I was just telling, like, that is fine that you are getting some of the overfitting issues up here. If possible, try and use any of the pre-trained model and see how, like, what is the accuracy level you are getting there, and check if there is any overfitting issue also you are getting over there or not. Try and add small epochs because your data size is large. Try and use for at least 5 to 10 epochs. Don't go for large epochs, but
Yes, ma'am.
try and see with any of our like pre-trained model how it is working. Okay.
Oh, okay, ma'am. I will try to do that.
Okay. Yeah. Fine. Okay, Sajid.
Thank you.
You can just stop your screen
Thank you.
sharing. Apart from that, that was a nice try from your end.
Thank you, ma'am.
Okay. Next is Dikshant. Dikshant, you're there.
Yes.
You can just share your screen, Dikshant. Yeah. Screen is visible. You can start your presentation.
Okay. Hello everyone. Today's my project is credit card fraud detection. The main goal of this project is to build a machine learning model that can detect whether a transaction, credit card transaction is fraudulent or not. Because it is very important that to check or to verify that fraudulent transactions are rare but costly. So in this project, we will go step by step, starting from exploring our data set, doing some analysis and preparing that data and model evaluation. First, I have imported some libraries. Now we are looking at the first few rows of our data set. Uh, this is the data set easily available on Kaggle. Our data set contain around 2,84,807 transactions. Out of these, only 492 are fraudulent. That means that fraud transactions less than are very less compared to normal transactions. So we can clearly see one big challenge that data set is highly imbalanced. Like most transactions are normal, but very few are fraud. Here we are checking the first few rows, then the shape of the data set, some information about the columns. We are checking if the data set contain any missing values. Luckily, we don't have any missing value. Uh, Here, zero represent non-fraudulent cases and one represent fraud cases. Second step is exploratory data analysis. We we are now exploring the data a little more. First, we checked for the missing values. The good news is like we have already checked there are no missing values. But then we looked at the class distribution. We made a bar chart of fraud versus non-fraud transaction counts. The graph clearly shows a huge imbalance, like almost all transactions are non-fraud. Only a few are the represent the fraud. Next, we check that transaction amount distribution. We notice that fraud transactions are usually smaller amount, while non-fraud transactions are very widely with many high-value transactions. Then we created a correlation heat map. Most of the features are not strongly correlated with each other, but some features like V17, uh, V14, V12 shows a stronger relationship with the class column, which means that these features might be more important in detecting fraud in our model. Third step is data pre-processing. The data set was already clean, so we just needed to make 2 or 3 adjustments. First, I removed the time column, which wasn't very useful, so we dropped it. Then the amount column had very different scales compared to other features, so we applied standard scaling to normalize it. After that, we split the data set into training and testing sets. We use 80% of data for training and 20% for testing, while keeping the fraud ratio of both balance using stratified sampling. Finally, we can see that we had like 227,000 samples for training and 57,000 for testing. Next step is model building. We use a neural network because it can capture complex patterns in fraud data. For our model, we decided to use ANN. I use MLP classifier, which works like a neural network. Our network had 29 features, input layers, 2 hidden layers with 32 and 16 neurons, and ReLU activation function and activation output layer with sigmoid activation. We trained this model on our training dataset. Next step is model evaluation. Uh, like we use several matrices to evaluate our model, like accuracy, precision, recall, F1 score, RUC curve, and AUC. Here we can see that our model's accuracy is 99.94%, precision is around 90%, recall 73%. Accuracy looks very high, but it's not enough because the data set is very imbalanced. Precision means like when the model predicts fraud, it corrects 90% of the time. Now I have made some confusion metrics. It showed that the most non-fraud cases were predicted correctly, and most fraud cases were also detected, but some were still missing. This is expected because catching 100% of our fraud is very difficult. That I made is ROC curve. Uh, the curve was very close to the top left corner, which means that our model performs very well in distinguishing between fraud and non-fraud transactions. To compare our model, I also built a logistic regression baseline model. We can see that it gives slightly lower results like precision of 82% and recall of 64. Which means that we also tested undersampling model and oversampling. The model detected all fraud cases 100%. But here in this model, the overall accuracy dropped to around 50% and precision to also 50%. This shows that while undersampling and oversampling, the balance the data, it loses too much information. So our neural network work best with the original dataset and ANN model. Last is our conclusion. Fraud detection is highly imbalanced pattern. I have already shown, our EDA showed the fraud cases are rare but often involve smaller amounts. Our ANN model perform very well with high accuracy and ROC curve, but and our logistic regression was decent, but it showed lesser uh, accuracy and sampling. That's all about.
Okay. Okay, Dikshant, you can just stop your screen sharing. So who wants to present next?
I'm Chetan.
Okay. Okay, Chetan, you can just share your screen. Yeah, screen is visible. You can start your presentation.
Okay. So good evening. I'll be presenting my project on heart disease prediction. So it is a machine learning pipeline that predicts whether a person is likely to have heart disease or not based on clinical data. So we will go step by step starting from the data set. So the objective, first of all, the objective of this project is to um, use use patient clinical attributes like age, cholesterol, blood pressure, and other medical details to predict the presence of heart disease. For this, we use a classification model, specifically an uh, artificial neural network, which is AN1, and evaluate it using multiple performance metrics. So going on to the dataset, we use the dataset called heart.csv, which is derived from the UCI Cleveland disease dataset. So it contains 1025 rows and 14 columns. So it has attributes like age, sex, CP, and test cholesterol, etc., etc. So here we have performed pre-processing. Checking for missing values, encoding categorical variables like chest pain, slope, and etc. Splitting the dataset into training using an 80-20 split. 80-20 split, standardizing the feature values with standard scalar so that all features are on a similar scale. So we have splitted the data into 80 or 20 scale. So next we can move on to the model structure. For the model structure, we use neural network built with Keras. The architecture looks like this, and the input layer that matches the number of features, hidden layer with 64 neurons, RELU, activation and dropout for regularization. Another hidden layer with 32 neurons, again with dropout. And an output layer with sigmoid activation, since this is a binary classification problem. So moving on to the training section. We are training the model using Adam optimizer with the binary cross entropy as the loss function. So the metrics we monitor are accuracy, precision, recall, and EOC. We also sorry We also use early stopping to stop training uh, if the validation loss doesn't improve. Uh, yeah, sorry, doesn't improve, which prevents unnecessary computation and overfitting. The model is trained on 100 epochs with the batch size 32. This is the training which I've trained. We got accuracy around 97. So in the evaluation, after the training, we evaluate the model on the test set. We generate a classification report which shows precision, recall, F1 score, and accuracy. We also compute the confusion matrix, which shows um, how many predictions were correct and how many were misclassified. Yeah, how many were misclassified. Finally, we calculate the ROC and EAUC score, which measures how well the model separates the two classes. Here it is. So training loss curve. This plot shows how the training and validation loss decreased over epochs. Mm. A smooth downward trend indicates that the model is learning well. And in this accuracy curve, here we plot training and validation accuracy, both curves increasing and stabilizing shows that the model is generalizing well to unseen data. And at last, this is the rock curve, ROC curve. This curve plots the true positive rate, yeah, the true positive rate against the false positive rate. Um, these are the dependencies which we used, Python and all. So in conclusion, this project successfully demonstrates how we can use machine learning to predict heart diseases. The model provides good accuracy, and if capable of identifying patterns in patient health data that are associated with heart disease. So, although improvements and further work can be done, this project provides a strong foundation for predictive health analytics. That's it, ma'am.
Okay, Chetan. You can just stop your screen sharing. So who next wants to present?
Thank you, ma'am.
Guys who want to present next?
May I?
Yeah, definitely. You can.
Okay, ma'am.
You can just share your screen.
Okay. Is this visible, ma'am?
Yeah, visible.
Okay. My project title is Air Quality Index Predictor. I have taken the dataset from the Kaggle Global Air Quality Dataset. The main objective of this project is to predict the AQI index of the predict the AQI index using the polluted concentration and weather conditions. This is the overall overview of the table. Pre-processing, like step, we are cleaning and encoding and scaling the data. Model architecture, we are using regression using artificial neural network. Training with optimizers like Adam and number of epochs. Evaluation, we are using mean absolute error and root mean squared error for evaluation. Extensions like such an expansion for the future projects. Tools we are using like Keras, Pandas, and Skykit for learning. This is basically the phase one problem understanding. Goal estimates the AQI value from environmental factors and provide alert about the air quality status. These are the use cases which we can use this predictor in business and social use cases. Government agencies can monitor the pollution and for citizen, and it also used in healthcare and smart cities to maintain the AQI prediction and planning and control. Next phase is dataset loading. Here we are basically loading the required libraries and functions. These are the required required libraries, pandas, numpy, matplotlib, and here basically we are importing and loading the dataset, global air quality dataset, that's CSV. Here we can see the shape and columns and head and missing values, which will be shown here. Yeah, here is a shape which contains 10,000 rows and 12 columns. Uh, these are the data contained in each column, which shows the top 5 values which we used for head. And these are there is no missing values. Basically, it is a clean data set. These are the histogram for numerical values, which shows the uh, uh, representation of the pollutant distribution across their values. Next phase is pre-processing. We are cleaning and AQI calculation, featuring and scaling. Here we are basically first turning the data into date time format. The next step, we are creating a function called helper function, which is used to predict the AQI calculation. We are basically breaking up the breakpoints for PM35, which is basically a environmental parameter, which mainly responsible for AQI calculation. Basically, we are creating breakpoints for PM25 and PM10. Uh, then the function interrupt subindex, where basically C is the concentration and BP table, which we have listed out here. For it basically checks for a low and high value and range lowest and highest range in the table, and it basically next check if the value is falling in under which condition. Then it follows the linear interpolation formula to find out the AQI subindex. Next step, we are finding out AQI subindex. Similarly, by using this same function, and for NO2, SO2, and CO and O3, we are not finding out through the formula. We are directly just finding out through the linear mechanism. By directly, we are dividing by 400 and multiplying to 500. By keeping all the maximum values in the subindices of this function, we can find out the maximum AQI from these values, which will be their final AQI level for the value. Next step, we are featuring the uh, values which need to be trained and scaled. Here we are taking X as a DF features. We have which we have taken only the main features like PM 2.5, 10, NO2, SO2, CO, O2, temperature, humidity, and wind speed. Now we are creating a AQI as a separate column in the data frame. Then finding out the AQI for all the values. Now we are splitting the train test split, which test size is to 0.20, which means 20% of the test size, and training is 80%. Now fitting the data into the min-max scaler to get the value in range from 0 to 1. Yeah, we have basically trained the shape, which basically comes under after training is 8,000 rows and 9 columns. These are the visualizations for this correlation heat map, which shows that O2 O2 is most significantly affects this heat map, and temperature. Similarly, they affect the heat map and distribution of AQI values, uh, which uh, which ranges from 0 to 300 basically. More than 300 is maybe something like it's maybe extra content. The next step is phase 4, model architecture, ANN for regression. Input dimensions, which we previously created features, which we are getting here for building up the next step, model architecture. We are defining build a regression model. We are choosing a sequential model. We are creating a first hidden layer with 64 neurons, activation function with ReLU for finding the nonlinear patterns. Input shapes are input dimensions, as we have previously featured. Those features will be their input dimensions. Batch normalization, which normalizes the output of the previous layers during the training, and dropout, which randomly drops 30% of the trained data after the completion of the hidden layer. In second hidden layer, we have 32 neurons. Activation layer is ReLU, and batch normalization, which basically keeps the fast and easy processing. Then here finally we are using one neuron which is using linear activation function, which is suitable for regression. Here we finally built a model and we are giving the input dimensions. Now we can get the summary of the model. Layer dense 18, which gives the output parameters of 640, and batch normalization gives 256, and second dropout, its dropout removes 0 parameters, and dense 19 gives 2080 parameters, and batch normalization gives 128 parameters. The dense gives 33 parameters. Uh, Now total parameters are 3137, and trainable parameters are 20945, and non-trainable are 192. This tabular regression, you can change the layer sizes and uh, based on the need. Phase 5, training, epoch, and batch size and optimizer. Optimizer, for this model, we are using optimizer ADAM for adaptive learning rate and fast convergence, loss mean squared error, and metric mean absolute error. We are giving epoch value for 50 and batch size is 32, which the model views the data set for 50 times for a batch size of 32. Early stopping method is being used here for finding out if any validation loss, which does not improve for 5 epochs. It prevents the overfitting and reduce the wasting time. And it also finds the best weight from the early stopping. Now we are fitting the model into the with all the trained X trained data and Y trained data and validation split. We are giving validation split for 15% of data and epochs with epochs and callback early stopping. Verbose is 1. Here we can see that at the final epochs there is 1294 loss and mean absolute error of 16.2269 and value error of 1151. This is a reasonable starting point uses early future of in future training. Visualization from this previous code. These are the visualizations. Here we can see that the train mean squared error is reduced accordingly to after the 10 epochs. The mean squared error is being reduced and there is gradually reduced from 10 to 30. In next graph, similarly here also mean absolute error is also being reduced from 0 to 10 and gradually maintained till 30. Next step is evaluation, where we are using regression metrics MAE, uh, uh, RMSE, and R square. Why predict this model evaluation? We are predicting the model and predicting the scale with these are the regression metrics: mean absolute error and mean squared error, and RSME and R2 score. We are printing them, and we are also creating another helper function to categorize the AQI category. Basically, we are categorizing the AQI by based on their value. If the AQI index is less than 50, then it will be coming under the good category. And based on the numbers, the categories will be changed. Now we are also testing the category with the values and also predicting the categories and values. These are the print functions. Based on these are the outputs. The regression metrics shows that maximum absolute error is 8.02, which is less, so it is no problem. And R2 square is 0.8, which is good. And accuracy is 0.90. The classification report is being shown for all the categories. Confusion matrix is for all the categories from good to hazardous. Here we can see that actual and predicted AQI which basically falls on the same line, uh, which means that the prediction and actual is being actually correct. Error distribution, which is being raised in zero, and after that there is no errors is being found. Sorry, actually there is no errors being found with this model. Uh, Next is a confusion matrix for AQI category. Here we can see that unhealthy, and moderate. These are the major categories which contains most of their values. Predictor categories which contains most of the values. These are the visualizations which from this. Okay. The next step, we are quickly predicting a real-time interface from this project, so that we are creating a predict single with a sample dictionary, a scalar and model. We are importing necessary numpy and features with the same features which we use to train the model. In order in same features, we are scaling and transforming the array, and we are predicting the model using the scaled values features, and we are returning the predicted AQI and category. I have imported two examples with example values. So here is the predicted AQI score and category. Basically, as we seen before, category which falls within 50, which comes under the category of good, and after 50 to 100, it will be moderate. Uh, this is an execution of simple single output, new reading. Extensions, we have used Python, Pandas, Scikit, and these are the trains with data used for pre-processing and data handling. And machine learning, TensorFlow, Keras, sequential dense dropout, batch normalization, early stoppings are being used. Visualization, Matplotlib and Seaborn is being used. In summary, as a uh, based on the pollutant concentration and metadata, provides divided and distinct phases problem, and understanding the dataset inspection and pre-processing and model architecture. Evaluation regression matrix is which shows that mean absolute error of 8.398 and RMSE score of 28.35, R square score of 0.8, and we are also have classification metrics as we have previously converted the categories from good to hazardous, where this model achieves 90% of accuracy, predicts the correct AQI category. High performance on regressions, effective categorical predictions, and feature correlation. These are the important insights from this project. Conclusion, it is a powerful tool for predicting and monitoring air quality. Its strong performance by both numeric regression and category classification demonstrate practically utility, and this project provides robust foundation and potential extensions. We can also advance more with like time series analysis and real-time forecasting and building a dashboard. These are being more advanced options for potential extensions for this project. Thank you, ma'am.
Okay, okay, got it, fine. So, okay, you can just stop your screen sharing.
Thank you, ma'am. Ma'am,
Oh,
again,
yeah.
I need to record the video for submitting, ma'am.
No, no, no. You have already presented in the session, so you don't have to like create any presentation video. You can just go ahead and fill the other details up and can submit.
Thank you, ma'am. Thank you.
Okay. Yeah. So guys, I just wanted to ask you, all of like whoever have done are done with all this week till week 5 project has been done. So I just wanted to ask you, have you just gone ahead and uploaded your project in GitHub?
Yes, ma'am, I did. Yes, ma'am.
Okay, so I
Yes,
just
ma'am.
wanted to
Yes,
confirm
ma'am.
that this is the mandatory field. So whoever have done, that's great, and who have not done, please try and do it. Fine. So that you
Okay, ma'am.
need to just put the details up of your project in your GitHub. Okay,
Okay, ma'am.
and great. So today, the like this week is actually the final week, that is week six. So we'll see in details about the deployment part of the projects, how we can go ahead, deploy our project and gain like useful insights, and eventually we'll try and understand how we can make our project better where we are lacking. These things we will be discussing from tomorrow's session. Okay. So first we'll see how we can go ahead with the deployment part. What are the basic needs of the deployment, and in one project, and how in different forms we can deploy a single project. That we will be seeing. Along with that, we'll just discuss about how we can do effective ways, make effective ways actually to make ourselves better and make our project better, so that like it is more appealing, and eventually it is giving more insightful information, and we can just that carries a specific value. The project carries a specific value. Okay, guys.
Yes, ma'am.
Yes,
Okay.
ma'am.
So for today, we'll just wrap up our session today here. We'll meet tomorrow again, and we'll continue with the sessions and the discussions. So we'll just, after the session, for this week, after the session, we'll just try and keep a window of around 10-15 minutes where we will be discussing, like, if you are facing any issue, you can directly tell it to me, like based on any project we can discuss, and eventually within yourselves also we will be keeping it on so that everyone can discuss in the same platform. Okay.
Yes, ma'am.
Yes,
Yeah,
ma'am.
great. So we'll meet tomorrow. So bye for today, guys. Bye, good night, thank you.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, bye
Thank you,
bye.
ma'am.
Thank you, bye bye.